And then with gallium, we go back to 4p. Okay? You want to do gallium?
No.
Okay, let's do gallium. I'm going to do gallium now. You know where they first discovered gallium? Yeah, that's right.
Oh my God.
No, I'm kidding. It's a joke.
Dang.
I was going to say a Roman ship, but
Nah. That's supposed to be a joke.
yeah.
Okay.
What do they call Roman ships? Roman warships. Galleys. They call them galleys. Yeah, it was discovered by Galileo. That was it. Okay. Alright, so when we get to gallium then, we've completely filled the 3D sublevel. Here's gallium right here. Completely filled the 3D sublevel. And we just need one more electron. Okay? And then we're going to go back to 4p. We can't go to 3p. We've already filled up 3p. So it's got to go into the next primary level, 4p. So we just need one electron there. Boom. Yep. There you go. Boom, dropping some chemistry on you.
I have a chemistry joke.
You have a chemistry joke?
Yes.
Okay.
That's why I saw it. When you call jokes about cobalt, radon, and
Yttrium, cobalt, radon, C-O-R, what? Really? N-Y? Okay.
R-N-Y.
Corny, okay. Got it. Got it. All right.
I have like 1,000 chemistry jokes.
You have 1,000 chemistry jokes?
Not 1,000, but I have like so many chemistry
Oh my gosh,
jokes.
you have
Okay.
one. Please.
No,
All right.
they're all good.
Does everybody have this?
No.
Okay, give you a second. Yep. Yes. So the question was, when we get to the 5th primary level, so we're just about to finish up the 4th primary level. The 5th primary level, this is 5S and 5S, and then we get to 4D. We drop back one there. So the next row works exactly the same way. Okay? The next row works exactly the same way. Do we want to practice any in the next row?
No.
Yes.
No.
Do we? Everybody's saying no except one person. Should we let her veto it or what? I mean, I don't know. Okay. You're okay? All right. Yes.
On the thing up there, what's under MN?
What's under MN?
Why isn't there anything under MN?
Oh, because the student didn't do their work.
Student didn't do that work.
Mm-hmm.
That's what we're going to go.
TC is missing up there. Technetium is missing on the periodic table. The element cube periodic table? Okay. All right. Okay. All right. Well, if everybody's okay with it, I'd like to skip to the 6th row now. Can I skip to the 6th row?
Yes.
All right.
What if it doesn't fit on one row?
Hmm? What? What?
What if it doesn't fit on one row? Do we have to do a paper like that? Or
We're
can we
skipping
skip
to
down?
another row, right?
Yeah, but see, I'm turning it sideways because now we're getting so much stuff. It's kind of you could go to another row if you wanted to. Well, I turn it from portrait to landscape. Okay. From hot dog to hamburger. I don't know. Okay.
Are you ever going to have to pull, like, from another number? Like, are you going to have to, is 4S always going to be, like, what you pull from?
Yes.
So you'll like never have to pull.
You only pull from the next highest S sublevel.
Okay.
The next high, everybody got that? If you pull an electron, you only pull it from the next highest S sublevel. All right, we're going to do just one more for the day's over, okay? Just one more. I want to introduce you to Fs. I know honor students hate to hear that, don't they?
Let's just not do it.
Let's do cerium. Cerium. All right. I may have to go to more than one row down here too. Oh. So you guys can, so you can recover. We're doing this one before you leave, so you can recover from your writer's cramp.
Or we could just sit around and I can tell what time it's
And we could. If I think of one while I'm writing, I'll do that. Or if Marissa thinks of one, I guess. So someone was asking about, did we drop down to 4D? Here we are dropping to 4D. All right, let's go on down to 6S down here. Hmm? So far I've gotten enough electrons for barium. So after 6S, then I've got to drop back one level for D. That's 5D. 1, 2, 3, 4, 5, and one electron. There's lanthanum. And look where we go for cerium. Look on your periodic table and look where we go for cerium. Now we're in the F sublevel. So we're only going to put one electron in 5D, and then we're going to drop to 4F. Okay? We're just following the numbers, okay? Really. Except for that strange stuff we pull electrons out of 4S. We're just following the numbers here. Okay? That's all you got to do, except for that. If you follow the numbers, you'll know you're in 4F now. No, we're not done yet. All right, so look and tell me how many elements do we have across the row in the F sublevels? Huh? 14. It's a lowercase f. I'm sorry. All right. All these are lowercase numbers. All right, so we need, how many orbitals do we need? 7. 1, 2, 3, 4, 5, 6, 7. So for cerium, how many more electrons do I need? There you go. That's okay. And there's no switching up, no pulling electrons out to, for that last box or anything in F, okay? You just follow the school bus rule for F. All right? So all the way through F, it's one in each box and come back, pair them up. Got that? Huh? Then we'll go back and fill up 5D. That's correct. But then there's one last tricky little thing you got to know about, and then we'll be done with all the tricky stuff. Okay? All right. Now, and we'll do that tomorrow. Now listen. So tonight you need to finish that. If you haven't already done it, you need to get those proposals done tonight. Right? Bring balloons tomorrow. Those are the only two things you got to worry about tonight. Now, if you have time, if you already done most of your research and everything, you have time, then you can start working on your annotations of this Monday. Okay, otherwise it is doing like that. Okay, so I kind of like shifted some of it back to give you a chance to shift things where you need it.
You said just do page 100 still on that.
Yes, just to page 100. Okay. To copy what? Oh, you get a copy. Yes, that's fine. That's fine. All right. Are there any other questions, folks? I'm letting you break down a little bit early. I felt that was a good place to stop. You got a question? All right. Hey. Be respectful. Come on. All right. Our poor sick guy over here's got a question. All right. Go ahead.
It pulls down a electron from 4s.
Yep.
Because there's too much kinetic energy in that element, so it drops it down.
It's not kinetic energy. That thing that you wouldn't call it kinetic energy that's resulting in this.
In the packet it said that the farther you get out from
Oh, now that when the okay.
the electrons have kinetic energy.
Yeah. Yes, but that's not the reason they pull them back in. Okay, it pulls it back in. Wow, I don't want to get too complex with it. If you think about how much extra area we're adding every time we add another layer to that, making that ball bigger on the outside, and that makes that layer, that primary energy level layer, a lot more space out there. So if I've got more room to stick more stuff in there, that's what it wants to do. Now there's something called the shielding effect that's going on here too. A lot of these effects are kind of interplaying here. And the shielding effect keeps the nucleus from pulling as tightly on the outermost electrons. So if there's only 1 or 2 electrons out there, it's kind of hard to hold on to those. When I get to that third electron out there, then it pulls, you got more protons in the nucleus, and it kind of pulls them back into that next level too. That's part of the effect. That's one way to think about it. Okay? I'm sure somebody who's an expert in that would explain it in a much more complex way, but that's the simplest way I can think of to explain it to you. Okay, I love blowing your mind, but, yes. Hey, wait a minute, hold it. You see all these people in here talking right now? Just how rude is that? Come on, guys. And I'm recording this, too. Your mamas and daddies could be listening to this. Don't let me call you out by name. All right, please. I'm trying to hear the questions, okay? Come on. Yeah.
Why did you skip all those classes not completed?
Because that's what happens. And you just follow the yellow brick road here. Where's that? Here we go. See, just follow the numbers. We get to 57, go to 58. That's what it does. Okay? And it has to do with what I was explaining to Brian about space available and the pull of the nucleus on the outer electrons and all those kind of things fit into the whole process. Okay? All right.
Can I show you something?
You can show me, well, as long as it's reasonable, sure.